Hey there guys, so today we're going to be taking a look at this mini PC that I got sent to me by ALLIWAVA. Don't really know if that's how you're supposed to pronounce the company name or not, but they did send me this mini PC to take a look at, so I'm kind of excited to see. Now this is a surprisingly big box for a mini PC. And as you can see, it also is very basically labeled here in the front. All it says is desktop mini PC. That is what you're getting out of it. Now we can run through the specs on the back right here. We can see what the options are. Now it does come with an i9-12900HK, a CPU that has been around for quite a while, and you still see brand new systems coming out with it. Now this does have 32 gigabytes of RAM, so you can see two 16 gigabyte DIMMs, a 1 terabyte SSD. It apparently supports a SATA SSD expansion. It does say hard drive there, but there is no reason for you to ever buy a 2.5-inch hard drive in any capacity. And it does have Wi-Fi 6E as well as Bluetooth 5.0. And power-wise, it is a 120-watt power adapter. That's not surprising for a system like this. But if we pop this box open, we should be able to see what the system actually looks like. Wow. Okay. I kind of understand now why it's such a big box. This system is going to be kind of massive. This is wow, this thing is bigger than I was expecting it to be. Okay, here's the tab to take this off. Just pop this out, because what an interesting design. Okay, well, that sure is something. It says Mod 01 Cyberpunk here. Pay attention to the host model. What does that mean? Now, I will say this is a plastic construction. This isn't metal. You can see it is plastic there. Now they have all of the I/O here. We do have two Ethernet ports. So we have the dual Ethernet. We have an HDMI, a display port, and two USB 3.0 ports as well as the power adapter there. On the front, we do have USB-C, we have the power button, we have a headphone jack, and two USB 3.0s. So not a lot of I/O here, but I guess in theory it's supposed to be like this. Obviously, you'll be able to see the whole system from different angles, but that is that's a very interesting design. I didn't look too much into the system. They just said if I wanted to take a look at some of their systems, I said yes, and this is the one that they sent me. Okay, I was hoping the manual would say something about potentially opening up the system, but literally all it does is label what each individual thing is. Like, it doesn't even say in detail anything. It just says, for example, LAN port, HDMI display port, no specifications about it or anything like that. Doesn't say anything about the USB ports either. So very, very bare bones manual. I am curious how you could potentially get in here, but imagine in theory there is a way. Oh, wait. Okay, yeah, you kind of just pry this thing open. Oh wait, it does have some screws here, so I'm gonna get those out before I end up breaking this thing apart. Let's make sure that these are screws that you're supposed to take out, because this part right here is really the only thing that was giving me any resistance at all. Okay, yeah, it comes off very easily. Okay, and yeah, you can see pretty standard looking board there. Of course, we have the two DIMMs there. We do have the single NVMe slot. Did say that it has 2.5-inch SATA, and of course it does come with the little adapter thing that you have to plug into this tiny little port right here. In terms of mounting the drive though, where would that go? Yeah, I'm not really 100% sure where you're supposed to mount a 2.5-inch drive. You know, it doesn't seem like the other side is really meant to open. So I don't necessarily find any real mounting slots or anything for the 2.5-inch drive, which is a little unfortunate there. Of course, we do have the power brick. You can see here, yep, it is a 120-watt brick. You can see it's specified right there. Yep, 120 watts. And of course we get an HDMI cable. Now this is certainly an interesting design, though the lack of any clear mounting points for the 2.5-inch SSD is very disappointing to see, though realistically speaking the kind of drives that you would even find available in that form factor at this point are going to be pretty bad ones. So it's not the biggest loss, though having only one NVMe is kind of rough. But let's get this thing back together and we can take a look a little bit more at the hardware before we jump jump into the testing. Now, I have to figure out the orientation here. Okay, yeah, it's like this. Okay. The panel does feel like it comes off very, very easily. So if it didn't have these screws, I could very easily see that coming open in any kind of, anything hitting this would essentially just pop it off. Now, it does have also this rubber base here. So in theory, you just plop it down like that, and that's the system. It's definitely a pretty slim form factor. Gotta make sure all the clips are popped in. There is a little bit of give there, you can see. So again, not the highest quality design in all honesty. It certainly looks unique, but that doesn't necessarily translate to it being a good design. But of course, the aesthetics are just part of the whole experience. What we really have to do is plug this thing in and take a look at how it performs. So let's do that right now.
So after running through all the Windows updates and driver installations, we're up and running here. We of course do have the Iris Xe 96 execution units version with the i9-12900HK, and I'm running Rainbow Six Siege X. So this is the updated built-in benchmark. We are running at the lowest in-game graphics settings, and I am using FSR 2.0 with the ultra quality preset. And immediately you might be noticing that the CPU temperatures are looking ridiculously high. We are not far off at all from 100 degrees Celsius, and you can see that this is already causing some thermal throttling because the GPU is supposed to be able to go all the way up to 1.45 gigahertz, and we're not hitting that. We're struggling to even keep up with 1.25. So already some thermal throttling, and this made me want to go right into the BIOS immediately. Unfortunately, this system has a very, very bare bones BIOS, and in fact, I also noticed that secure boot was disabled. So I enabled that just because if I want to test out any games that require that, it'll just be on. But there is not much you can do in the BIOS at all. You can go in there and configure power settings, but it caps out at 45 watts. You can go down to 40 watts or 35 watts. Outside of that, there's really not much you can do in the system itself, at least when it comes to the BIOS. So that's very unfortunate considering the temperatures that we're hitting here. There's no fan control or anything like that. We could lower the TDP, but then we're sacrificing performance there. So I decided to press on with the default settings. And to no surprise, we were still running into these thermal throttling issues because the temperatures that we're hitting are ridiculously high. At the start of the CS2 benchmark, we were already in the low to mid 90 degrees, and that means the system was thermal throttling. You can see that the GPU clock is not reaching the maximum speed of 1450 megahertz. We're at 1350 for most of it, and as the benchmark progresses, it will drop lower than that. And while the performance itself is decent considering we're running with the lowest in-game graphics settings, but with FSR disabled, it is at least keeping up better than the old Vega integrated graphics, but that doesn't necessarily matter because of the fact that we are, for one, thermal throttling, and I'm just concerned on running the system with these temperatures at all times. And it was again the same situation with Mountain Blade 2 Bannerlord. With the lowest in-game graphics settings, while the performance itself is decent, not really incredible by any means, but well in line with what you would expect with this type of integrated graphics, the disappointing thing is that we're not maximizing the performance of this system. On paper, we should at least be performing slightly better than this. And again, you can see that as the benchmark progresses, the GPU clock is going down more and more, and you'll see that our power utilization is not reaching that 45 watts that it's supposed to. It's because the system is thermal throttling. It essentially has to drop the amount of power that it's utilizing just to keep the temperatures in check, and it's struggling to do that by a pretty disastrous amount. I find that with the i9-12900HK, at least on the systems that I've tested, going up to 60 watts can really improve your performance, and the fact that we're getting this bad a temperature at 45 watts is pretty bad, which means that we're not really getting the best that we can out of a chip like this. The system system is really incapable of even letting you do that. But we're not even getting the 45 watts that we're supposed to here. In fact, I was so curious how bad things could get that I decided to just boot up Far Cry 5 and sit there and play for about 40 minutes just to see what the temperature would end up being like and what the power utilization would be. And you'll see here that this, towards the end of the run that I was doing, the GPU clock is struggling to even reach 1200 megahertz. We're really sticking more to around 1150, and that's not great considering that we're supposed to be able to go all the way up to 1450 megahertz. It's just not doing a good job. The power utilization does fluctuate up into higher levels towards the low 40s, not really reaching the mid 40s that it's supposed to, but it fluctuates a lot. And you can see that even with the lowest in-game graphics settings, we're not exactly getting a good result here. It was really more of a console-like experience, and I do mean PS4 era console, but it definitely was very rough. And so I decided to also run Cinebench R23 just to see what the numbers would look like if we were fully utilizing the CPU as opposed to just maxing out the GPU and using some of the CPU. You know, this is a 14-core part, and well, the results weren't exactly spectacular. We were looking at levels of performance that were below even the Ryzen 7 5825U. Now, at 60 watts, this chip can perform really well, beating out a Ryzen Z1 Extreme, though not quite reaching things like the Ryzen 7 7840HS, but still giving a pretty great result with 60 watts, but this time around it just was not giving us that at all, or even remotely close to that. Now, the difference between the 45 watts and 60 watts isn't this drastic. This isn't even giving us the performance that it should be at 45 watts, and that's really disappointing to see. Now, I didn't end up bringing up any kind of temperature testing software while I did Cinebench R23, but I did test it out in Cinebench 2024, and that pretty much confirmed what we already knew. The system was thermal throttling by a pretty significant amount. The maximum core temperature that we saw was 98 degrees Celsius, so these were some pretty disastrous results, and it kind of explained why we were having all of these issues and all of the different benchmarks that we ran here. I mean, the chip itself isn't going to be a great performer in a lot of games, but we're not even getting the full potential of it here, and especially considering that it's a 14-core part, you would want to at least get the maximum speed of a 45 watt TDP out of this, and you can't really get that. So this was really disappointing.
Okay, so what can I say about this thing? It is crap. It's just not a great system at all. It ran so hot that it was thermal throttling, both in the CPU heavy workload and GPU, because it never once hit its maximum GPU clock speeds. You know, the spec of this is supposed to clock all the way up to 1.45 gigahertz, and we never once touched that. In fact, we were struggling to even get past 1200 megahertz when we were gaming. So in extended use cases, it's not great, and it also is going to depend a lot on your ambient temperature. If you're somewhere in the world where it is hot and you don't have AC, this thing is going to thermal throttle even harder, because it was about 80 degrees Fahrenheit in here. You can see on the screen what it was in Celsius, and it was thermal throttling like crazy. If I had my AC off, it would have been even worse. And I'm almost curious if this thing is struggling because it doesn't have enough ventilation, because when you really look at it, there seems to be some ventilation here maybe, and a little bit at the top here. It almost just looks like a speaker grill. It could literally be that the fans in here are not breathing enough. Oh, there is also ventilation down here, but I don't know. You know what? We're already here. This thing isn't great anyway, so I'm just gonna open this thing up and just see if I can't take the board out and see if we can't take a look at it. In fact, if I can get the board out, I might just plug it in, run Cinebench on it, and see what kind of temperatures we're looking at. Because if there's an improvement there, then there is nothing more to say about this system other than it is a very bad design. And at the $500 price point that they're charging for this, you can get better systems. You know, I guess, you know, the company was willing to ship it out to me, but that does not guarantee them a good review, obviously. It's going to be all about the product, and this product just is not it. It's just not providing the level of performance that you would expect out of it. It's all around disappointing, really. Sure, it's a unique case design, but does that really matter if it doesn't give you a great experience? Okay, yeah, the board easily seems to come out. Ooh, the antennas are still hooked up there, though. Okay, well, since I don't need the Wi-Fi, and I don't want to rip out the antennas, I'm try to keep the little plastic cover that it has here still intact. No reason to remove that. I could just detach the antennas from there, but honestly, I'd rather just take out the whole card. That way I don't need to worry about it. I don't need it anyway. Put these screws in a magnetic attach tray. But okay, let's take a look at the cooling system. I mean, look, it's a decent sized heatsink. Obviously, it is a very big CPU, but yeah, the only way it can breathe is through the very, very obstructed ventilation that's happening here. You should be able to see the light shining through there. You can see it's mostly obstructed. It's not exactly great. So, okay, I'm gonna do it. I'm gonna plug this thing in, and I'm gonna see how it performs. Well, in theory, just use it like this, because if I put it down like this, then the fan's really not gonna be able to breathe. So we'll try it like this. It does have this this spacer here, this foam spacer. So I guess that'll serve as one of the legs, and then we do have all of this here. That'll be the other leg. I just want to run Cinebench on this, and I want to know how it performs. I believe this right here is the power button. So I'll try that in a second. Oh, before I do anything, I should probably install the M.2 back on there. All right, it is on there. So we'll flip this thing over, plug in the HDMI, plug in the Ethernet, and then I'll do the power. And let's see. Oh, never mind. This one's the power button. Okay, so we have the fan spinning now. So I'm gonna go onto the screen and everything, and I'm gonna set up Cinebench, and I want to see what temps we end up hitting.
So after getting the system up and running and opening up Cinebench 2024 and running it again, immediately I was kind of disappointed because we hit thermal throttling. So at this point I was ready to just assume that the whole system was a problem, but then immediately, as you can see right now, the temperatures are starting to drop, and they're dropping pretty dramatically. And well, the reason for that is that I noticed that the fan takes a little bit to ramp up. So it hit thermal throttling temperatures and it started to throttle back, but this fan speed also picked up pretty dramatically. And once it reached the speed that it's going to be at, its maximum speed, I imagine, the temperatures were not bad at all. By the end of the run, the temperature was really in the high 70s, which is not bad at all, considering that we were just at damn near 100 degrees Celsius. Going down to below 80 was a huge drop off, and it pretty much confirmed my suspicion that the CPU fan just cannot breathe with the horrible ventilation that they put onto the case. It's all just aesthetics over function, and I don't understand why. But at this point, I got so curious that I wanted to see what the numbers would be like in gaming. Oh, and if you were wondering if there was any improvement at all in the performance in Cinebench with this improved cooling, yeah, there was. We ended up seeing about a 50-point bump in Cinebench 2024. Not a substantial leap, it is still falling behind the 60-watt version of this chip, but that's really not something that we can overcome, but we are getting the full capabilities now of a 45-watt TDP. But of course, there was also an improvement in the gaming performance, where now we're able to reach the maximum clock speed of the iGPU, going all the way up to 1450 megahertz. And this came with a nice little bump in performance. While it wasn't earth-shattering and it's not going to lead to you being able to adjust any of your graphics settings going from, you know, the lowest up to medium or anything like that, what it did do is it stabilized the performance, and it put us comfortably above 60 FPS now instead of just barely being at it before. You know, considering that the FPS that we're at, this is a nice bump in overall performance, and this is exactly in line with what the system is supposed to be able to do, but I was also curious what the long term would be like if I sat down and played with this, similar to what I did with Far Cry 5. So I sat down and played through Far Cry 5 again for about 45 to maybe 50 minutes, and things were better. The temperature was a lot more reasonable, still relatively high, though not really by a dramatic amount. This is what you would expect for most laptop cooler configurations like this. But the point is that the CPU itself is not thermal throttling. The GPU is reaching its maximum clock speed, and this did end up improving our performance slightly, where there was less fluctuations, the frame times looked more consistent, and at least our 1% lows were just slightly above 30. So really, it's the housing that they have for this board that has made this a really bad deal. Now, I do think that $500 for an i9-12900HK mini PC in general isn't worthwhile, considering that similarly or cheaper priced AMD systems will perform better both CPU and GPU wise. But if you have a specific need for an Intel CPU on a mini PC and you're trying to get something that is more high power, this just is not the system to go with. It would be more interesting if they just sold us the board and didn't bother with the very poorly designed case. So I really don't know what else to say about this system. I'm very disappointed. I don't recommend it to anybody. The GH9 is just not a great offering. They do have an AMD system. They pretty much ended up sending me this and not the AMD one, and I think that they're probably going to regret doing that. The AMD one is a far more traditional mini PC, so I would expect it to hopefully perform better than this. But with this result out of this Intel system, I can't recommend this thing at all. It's probably one of the worst mini PCs that I've taken a look at. It reminds me of that Gen Machine mini PC, not the recent one, but the previous one with the Ryzen 7 2700U, where the case also was just suffocating the thing, where even with a 15-watt TDP, it was really struggling. Taking out the board and using it like this gave us a better result. And well, this is a similar case here, where the board itself like this, it's kind of interesting. You could probably 3D print your own case for this thing and get better performance. But of course, at $500, there's just no reason to buy this thing. I'm going to link down below some systems that I would recommend over this. The Silver 9 is one that I particularly liked. I don't know if that's still available though, but in general, I'll link down below some systems that I think are just better alternatives that you can get for cheaper. But I do not recommend this thing at all. It's awful. It's a bad system. Do not buy it. Anyways, I'll catch you guys in the next one.